Okay, so what we're going to look at next then is an arithmetic series. So we've just looked at arithmetic sequences, and that is a sequence of terms where they have kind of a common difference between them, so they're going up by the same amount each time. Okay, the difference between each term is the same. An arithmetic series is when we take the terms of an arithmetic sequence and we add them together. So for the example here, we've 1, 3, 5, 7 is an arithmetic sequence, but 1 plus 3 plus 5 plus 7 turns it into a series where we're adding those terms together. And a series is related to a sequence. Okay, so we have T representing those series, and now we're going to have S representing the sum of some of those terms. Okay, so you do have to think of your series as related to the sequence, and a lot of the time we'll be kind of moving between the two. Maybe we're working out values for t and values of tn, and then looking at how do we add those together. So if we have a series like this, where Sn is the sum of the first n terms, S1 obviously is the same as T1, S2 will be the sum of the first two terms, so T1 plus T2. S3 would be T1 plus T2 plus T3, and so on and so forth. Similar to Tn, we have a formula for looking for this, and this is our general formula here. Arithmetic series, and again this is in your log tables, same as we had with our arithmetic sequences. For our series, A is the first term, and that's the first term, T1, and D is the common difference. And you need to be careful here as well that D is the common difference between the terms T2 minus T1, exactly the same as we had before. So we will see that a lot of the time this comes up in terms of moving from a sequence and then looking into adding them up. So you will generally already have the values of A and D, but just be careful that D is the difference between the terms themselves, not the sums, not the series. So it's the difference between T2 and T1, or T3 and T4, not S2 and S1. So just be careful of that. So here we're asked to find Sn and hence find S20 of the series. Okay, and again this is fairly straightforward once we follow through the same method each time. So first of all, to find Sn, if we have our formula up here, we can see the two things we need are A and D. A is the first term in my sequence, so A will be 5. D then is going to be the common difference between my terms, so I look for that here. We can see that the difference between each of the terms in my sequence is 3. Then taking my formula, Sn is n over 2 by 2a plus n minus 1d. Filling in here, I'm leaving n because n should be in my formula. So we're looking for the formula for Sn, so n should be a value in my formula. The only two numbers I need to fill in are a and d. Okay, 2 times 5 is 10, gives me 3n. 3n minus 3, and following through, n over 2 is 3n plus 7. Okay, and I can stop at that point. That's perfectly fine to leave that there. We don't actually have to necessarily multiply it out. We may have to for the next parts, but we can leave it there for the time being. So what we're looking for next is going to be S20 of the series. S20. So to find S20, we're going to take our formula, and anywhere that we see n, we are going to sub in 20. Okay, anywhere that we see n, we will sub in 20. 3n plus 7. So sorry, 20 in there. Okay, and following this through, 10 times 60 plus 7, we get 10, 67, and we get 670. Okay, so the sum of the first 20 terms of my series is 670. So in terms of actually finding Sn and using Sn, it is quite similar to finding Tn. Okay, the only thing to be careful of obviously is your different formula. Your A and D come from exactly the same place, have exactly the same value, and finding S20 we sub 20 in for n then. What can happen is a question like the one below here, where we're given an arithmetic series and we're asked to find the value of n. Okay, and they tell us Sn is equal to a particular value, find the value of n. So really what we're saying is how many terms, so that value of n, sum of the first n terms. We want to know, well, what is n? So the sum of the first n terms is equal to 192, but what is n? How many terms do I have to add together? So same as we've had before, we look for A, we look for D. Okay, A is the first term, that's 5. D is the difference between them, that's going to be 2. My formula for Sn stays the same, n over 2 by 2a plus n minus 1 times d. We can fill in the values that we have. So we have a, we have d, but no more than that. That gives me 10 plus 2n minus 2, which gives me n over 2 is 2n plus 8. Okay, we have Sn. What we want now is that Sn is equal to 192. So let's take our formula for Sn. Instead of Sn, we'll write in the formula, and we'll put that equal to 192. Okay. So now at this point, we need to multiply out these brackets. Okay, and we have to be careful of doing this. So when we're multiplying out these brackets, we're doing n over 2 multiplied by 2n and n over 2 multiplied by 8. Okay, the usual, the way that we would multiply out our brackets. So n over 2 by 2n plus n over 2 by 8. Okay, that's just the standard way that we would multiply out our brackets. That gives me 2n squared over 2 plus 8n over 2. Okay, what we're doing there is just working with our fractions, thinking of that as maybe 2n over 1, if you like. We multiply the top by the top and the bottom by the bottom, and that gives me 2n squared over 2. 2n squared over 2 just breaks down to n squared. 8n over 2 goes down to 4n, equal to 192. And what we have now is a quadratic equation. We bring over that 192 to the other side, get a simple or a standard enough quadratic equation here. How you choose to solve the quadratic equation is up to you. What we look at here maybe is trying to use our quadratic formula, just because I know people are maybe most comfortable with doing that. So if I'm looking for my quadratic formula, n is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. Just saying n here because that's what I have in the formula. Instead of x in my quadratic, it's actually n. So then subbing in for all my values here, b squared minus 4ac. So b is 4, a is just 1, and c is 1 minus 192. Okay, and all over 2a, 2 times 1. Okay, following this through a little bit further. So minus 4 plus or minus, and you could sub this into your calculator at this point if you wanted to. So 4 multiplied by 192, so let's just work that one out. 4 multiplied by 192 gives me a total of 768 over 2 minus 4 plus or minus the square root of 16 plus that 768 gives me 784 over 2. Okay, what we're hoping for, obviously, and we saw in the last kind of example or in the last section, was making sure that that value of n that we end up with is a natural number. So that's, I suppose, one way of us making sure that the answer we've gotten is a valid answer. So getting the square root of that number, 784, gives us an answer of 28. So we get that n is minus 4 minus 28 over 2. Or n is minus 4 plus 28 over 2. So the n then is going to be equal to either minus 16 or n is going to be 12. And obviously n can't be a negative number. We can't have a negative term. So instead we just get that n is going to be equal to 12. Okay, so it's just following it through that way. So what we kind of saw here is setting your formula for Sn equal to a given answer, and then following that formula through the rest of the question. So using your formula, setting it equal, multiplying it out. A good example of maybe starting the question off by just following what we're given and then seeing where that question takes us. Okay, so we can only really go with where we're led to. Okay, we can't work through it for ourselves. We can't necessarily at the start of the question know exactly where we're going to end up going, But what you see is that with Sn, if you're given an answer, generally that's going to mean you need to do a quadratic. Something to be careful of is going to be this part here, multiplying out. Okay, be careful, make sure you're happy with that part. Okay, so from this bit on, making sure you're happy with multiplying it out and that you can multiply those out properly. If not, it's looking back at maybe algebra and kind of expanding brackets and things like that in algebra. Just making sure you're happy with those little steps, because that's the key thing.